Okay, number 5. Find the interval of convergence of the following power series. And this question is kind of the same as the finding the radius of convergence, except that for this one we need to check the boundary points. All right. So the first line or first step, of course, is trying to find the radius of convergence, and that is the limit of an over an plus 1. Remember, an is just the coefficients. And then put the absolute value, and then you simplify it and you find it's equal to 1. So the power series is convergent in this interval, whereas 2 is the center. Minus r and center plus r. R is here equal to 1, okay? That is 1, 2, 3. This is an open interval. Now let's check the boundary points 1 and 3. Now when x, okay, so let me explain what one means by checking the boundary points. I would like to see if when x is equal to 1, whether this series is convergent or not. If x is equal to 1 makes this series convergent, then x equals 1 should be included or added to this interval. Same for 3. Okay, so let's check. When x is equal to 1, what does this series look like? It looks like this. Sigma of negative 1 to the power of n, negative 1 to n, divided by root n. When x is 1, 1 minus 2, that's negative 1. Okay. Now, negative 1 to the n times negative 1 to the n, and it gives you 1. Okay. So this series becomes 1 over root n. This series is a p series. It's a p series, and you can see that p is equal to negative 1/2, which is greater than negative 1. So we know that it is divergent. And that tells you that x equals 1, in fact, should not be added to this interval. Now check the other one, x equals 3. And then the series becomes this. When x is 3, this 3 minus 2 is 1. 1 to the power, any power is again 1. So you don't see it here. Okay, so it's just negative 1 to the n divided by root n. And this series is convergent because it is a alternating series. And that means the signs of the terms are positive, negative, positive, negative, negative, positive, negative, positive all the time. And the absolute value of the general term, which is 1 over root n, is decreasing and approaching 0 when n is going to infinity. All right, 3 conditions. 1, it is the sign of the terms are alternating, and 2, the absolute value of the general term is decreasing. 3, the absolute value of the general term has limit 0. Okay, so we know that it is an alternating series, and according to alternating series testing, we know that this series is convergent. Alternating series is convergent. Okay, so the interval of convergence is 1, 2, 3. Be careful here. We have a bracket at 3. That means 3 is included. Because when x equals 3, this series is convergent. This b is almost identical. Okay, you find the radius of convergence and check the boundary points. You have to check both, because sometimes both over the 2 points are included. You need to be careful about that. Do not make any assumption. Number 6. Number 6 asks you to show that the following series are convergent. We have 2 questions here. Number 1, A. Okay, so for this one, you need to use the ratio test. To use the ratio test, write down the general term. Okay, here, the general term is an. It is not the same as the ratio, the formula for the radius of convergence. Okay, in that case, an is only the coefficient. But here, an is the general term in the sum. N plus 1 is just replace n with n plus 1, so you have this. And for the ratio test, you are supposed to take the limit of an plus 1 over an, absolute value. Okay, this is also different from the radius of convergence. In this case, you are taking the limit of an over an plus 1. An is in the numerator. But the ratio test, an is the denominator. Okay. All right, so write it down and take the quotient. And this is 2 over n plus 1. And it's obviously 0, so it's less than 1. When the limit is less than 1, we can say that this series is convergent. Second one, the general term is a power of something, so you need to use a root test. Write down an. Again, an is the general term, okay? So you take the nth root of the absolute value of an, and that gives you 1/3 minus 1 over 3n. Now you take the limit of the nth root, and that gives you 1/3, which is less than 1. So when it's less than 1, we can say that this series is convergent.